Girls, in this video, our objective today is to construct a power series from a rational expression. In order to do this, we must recall that if we have a geometric series in the form of a times r to the n, the summation of that is a over 1 minus r. So essentially, we're going to be given this or some form of this, and we're going to turn it into this. Okay? So let's do our first example. Let's say we have 4 minus x, and it's centered at 0. So from this, we want to put it in the form of a over 1 minus r. The first problem we see is that the 4 needs to be 1. Any suggestions on how we can make the 4 1? Well, if we divide everything, the numerator and the denominator, by 4, so if we divided that by 4 and divided the numerator by 4, we would get 3/4 over 1 minus x to the 4. Now, this is in the form of a 1 minus r. What is a? A is 3 over 4. And r is x over 4. So if I wanted to write that as a series, I can write it as a 3 to the 4th times r, which would be x over 4 to the nth power. And now we have changed it to a geometric function. A geometric series, sorry. We've changed it to a geometric series. Easy peasy? Okay, well, let's do another one. In this example, we have a center of -2. So recall that when we have a center of -2, we would have to write this as 4 minus x plus 2. It's plus 2 because remember we have to subtract it. Now, we cannot willy-nilly just add a 2 in there. Actually, we're subtracting 2 because if we distributed that, that would be minus 2. So I can't just willy-nilly subtract 2 from a function without adding 2 to that function to keep it balanced. So then I could write this as 3 over 4 plus 2 is 6 minus x plus 2. Now remember, our goal is to get it in the form of a over 1 minus r. That's our goal. So I would have to get rid of the 6. Again, I'm going to divide everything by 6, and I get 3 over 6, and then 6 over 6 is 1 minus x plus 2 all over 6. So that will give me 1/2 1 minus x plus 2 over 6. So if I take it back to my form, I have a, which is 1/2, and r, which would be x plus 2 over 6 to the n. Now, one thing we did not talk about is what is the radius of convergence for this. What is the radius of convergence? So remember, this is geometric. So this is going to converge when the absolute value of the radius is less than 1. So that means -1 is less than x plus 2 over 6 is less than 1. Now I'm running out of space for that, but we can see that that's going to be -6 is less than x plus 2 is less than 6. So -8 is less than x is less than 4. So that would be my radius of convergence for that. Okay? Let's try a different one. This one is similar to the one that we did. We have a center of 5. So remember, we have to write it, we start by writing the center, 13 over 2 minus x minus 5, because I'm always taking the opposite. Again, here I am adding 5, and I can't willy-nilly just add 5 without subtracting 5. So I have 13 over negative 3 minus x minus 5. Okay, so once again, I need the negative 3 to be 1, so I'm going to divide everything by negative 3, the top and the bottom. Okay, when I divide this by a negative 3, it makes it positive. So A is negative 13 over 3, but now R is going to equal to negative x minus 5 over 3. And the reason it's negative, because remember the formula is 1 minus R. So in order for that to make that true, R would have to be a negative here. So I get A times R to the nth power. A couple of different things that we can do with that. And there are different ways we can write that. One is we can take out the negative 13 and write this as negative 1 to the nth, and then x minus 5 to the nth over 3 to the n plus 1. Okay, because if this starts at 0, we get negative 13. Here we would get the same thing, because when we start at n equals 0, we're going to start with n plus 1. 0 plus 1 is 3. And we would start with the 1/3 that we have here. Okay? All righty. This one is going to be very similar to what we just did. Again, we're going to rewrite this to say f of x is equal to 3 over negative 1 plus 2x. We need this to be 1, so we get f of x is equal to negative 3, 1 minus 2x. So A is negative 3, and R is 2x. So this is negative 3, 2x to the nth. Now this one may look a little different, but it really isn't. It really isn't. We're going to do the same thing. We're going to divide by 4. So we get f of x is equal to 1 plus x squared over 4. So A is 1 and R is x squared over 4. Negative x squared over 4. So my summation would be 1, and then I'm going to take out that negative 1, and we're going to make that x squared over 4 raised to the nth power. Or if you want to be fancy, you can write it as negative 1 to the n, x to the 2n over 4 to the n. For this one, we don't have to do anything to it because it's exactly what we need. So we just have a is 2. R is x squared. It's exactly what we need. So it's just 2x to the 2n. Now, this one's a little different. Well, still not different because I can still just rearrange this and get 2x. I don't think I can do that because of the x's in the numerator. So we get x plus 1, x minus 1 factored. And we're going to have to make partial fractions. So we get 2x is equal to a times x minus 1 plus b times x plus 1. So if we let x equals 1, we get 2 is equal to 2b. So b is equal to 1. If we let x equals negative 1, we get negative 2 is equal to negative 2a. So a is 1. So we get 1 over x plus 1 plus 1 over x minus 1. So what do we do with that? Well, they're both in the form we need them to be. So we're going to write two summations. The first one we can write as 1 over 1 minus negative x. So that will give me a is 1, r is negative x. So our summation would be n equals 0, negative 1 to the n, x to the n. Plus, this one we could rewrite as 1 over negative 1 plus x, dividing both sides by a negative 1. I get negative 1 minus x. So that would be minus n equals 0, infinity, and my r is x to the n. And yeah, you can just add those two together. Okay, and this last one is similar to this one. We're going to have to do partial fractions again. So we have 3x over x plus 2, x minus 1, and that's going to equal to a over x plus 2 plus b over x minus 1. Finding a, so 3x is equal to a times x minus 1 plus b times x plus 2. It's very similar to what we did before. So if we let x equal to 1, we get 3 is equal to 3b. So b is equal to 1. If we let x equals negative 2, we get negative 6 is equal to negative 3a. So a is equal to 2. So we get 2 over 2 plus x plus 1 over negative 1 over 1 minus x. So once again, we just put it in our little form. So I have to divide by 2 here. So I get 1 over 1 plus x over 2, which makes r negative. So my summation would be negative 1 to the n x over 2. I'm not sure why I wrote that as squared. Confused me. I don't know why I wrote that as squared. That should just be x over 2. So negative 1 to the n, x divided by 2 to the n, minus the summation of x, a is 1, and r is x, so this is just x to the n. And that's what we got, and that's how you do that. So easy peasy. I will see you guys tomorrow.